record button. Cool. Like the lesson plan has this word in it, the word of the day, equifinality, and the definition of that is the property of allowing or having the same effect result from different events. And I think that's a good way to start this class off because what we're going to be talking about today are various techniques to achieve the same goal. They're like I think the thing with programming is that you could do things very differently but still get the same result. Like I expect all of your projects to look pretty different, but they still, will be doing the same thing. We'll be playing Game of War. And I think that's important to note that with programming, there is no one right answer to a problem, but there sure are a lot of wrong ones. And so today what we're going to do is that we're going to go through some conditionals, learn about booleans, and we're going to be talking about looping. All right, so can you all see my screen? Cool, I got some nods. I'm pretty sure you can hear me, otherwise you wouldn't have nodded. So that is problem 2 answered. And so when we talk about booleans, booleans were named after this classical, don't know if it's the right word, but very old mathematician named George Boole. And a boolean is a value that can be one of two things, true or false. And so when something is either true or false, it is a boolean. And so that relates to conditions. Conditions are an important part of programming, is that a condition is something that evaluates to a boolean. So the simplest way of this is that we can do, for example, we can set an array, a variable play, again, and we set that equal to false, right? And now when we refer to this variable play again, it returns us a false. And I want to note that this false is not a string false, but it's a very special kind of thing called a boolean, and that can be true or false. And so this here is a conditional in its most basic form, but usually how we use conditionals is we use conditionals by comparing two things together, right? And we have I'm going to post in your Slack channel a screenshot, and my dog is growling. First, I'm going to make a flow control thread for your questions about this class, and then I'm going to post this screenshot from the lesson plan that kind of goes over the important comparison operators. There are more. These are the ones you're going to be using for the most part. The double equals is equals to, greater than, or equal to. Most of these should seem familiar to you. You should have seen most of these back in the way back days in middle school, elementary school, somewhere in there, like when you were little. One of those classes, math classes. I think the two things that you've not seen, most likely seen previously, are the equal to, the double equal, and the not equal to. The double equal signs is comparing to see if two things are equal to each other, and that is a double equal because we want to be distinct from equal. And a single equal, as we've seen previously, is an assignment operator. So it's very important that you get in your head that the double equal is the comparison, the single equal is the assignment. This will save you a headache. And the bang equals, exclamation point, exclamation mark equals is saying like, hey, these are not equal. And so I'll show you how we can use them, right? Let us set a variable called mood, and we're going to set that to a string called hungry. I'm always hungry. This is not something I just made up. I'm literally hungry right now. And what we can do is that if we want to check to see if mood is hungry, we do it like this: mood double equals hungry. And when I hit enter, we see that this returns me true, a boolean. Like again, this is the boolean true and not the string true. And so we can see the other side of this. Mood double equals sleepy. For once in my life, I'm not currently sleepy. I'm hungry. And when I do this, I expect this to return false. And we see false, like that. What these operators do is it looks at the things on either side. So we can also kind of chain methods onto either side. So I'll give you an example of this. Hungry has 6 letters, right? And so I want to see if mood.length is greater than 5. .length is a method that we call on strings and will return us how many letters the string is. Hungry is 6, so mood.length is going to be greater than 5, and this should return us true. And we see this is true. And the kind of thing I want to also talk about when we use the basic enumerables, conditionals is the not equal to. If I were to say mood not equal to grumpy, I want to say, hey, am I not grumpy? Well, I am hungry, not grumpy. So this should be true, because the mood is not grumpy. As a general tip, I would say avoid using the nots as much as you can, because I think you get into the space where you get like you'll eventually hit like a double negative, and then you got to pause and be like, wait, not. There are cases where you'll have to use the not operator, but I think it's very important to, when you're starting to construct conditionals, to start thinking like, okay, so am I making this easier? Am I working, am I making this straightforward? And I think that one of the most important tools to help you do this is by saying it out loud. For example, this is like mood. Is the mood not grumpy? It is hungry, therefore not grumpy, therefore true. Never underestimate your ability to make sense of things by saying it out loud. I will talk out loud and kind of like explain what my code is doing out loud, because I think that engages different parts of your brain. I will write out what my code is doing on paper in like human English to verify. I'm like, hey, is this what it's actually doing? Like, I think a good approach to programming is to engage as many different parts of your brain as possible. Cool. Any questions at this point about these conditionals? Cool. All right. Oh, nope. All right. So let's kind of move on. The next thing I want to talk about is the negation operator, known as a bang. It will reverse something from one to the other. So, for example, bang false is going to give me the opposite of that, which is true. Bang true is going to be the opposite of that, which is false. Not much else to say about that. Just does the opposite. We also have other helpful methods that can be used as conditions. And again, like I think we had a discussion about this yesterday. The kind of syntax is that in Ruby, if we expect if a method has a question mark at the end of it, it generally means that this method is going to return a true or a false. So, for example, for integers, we have this method called even. And this will tell us if that integer is even or odd. So, is 1 even? I see some head shakes. It is not, therefore it's false. Is 2 even? Yes, it is. And of course, we have the opposite of that. Is 1 dot odd? Yes, it is. Is 2 odd? No, it is not. I think we showed you this in the past. Hello dot include h. Right? It does. Hello has the letter H in it. We also have hello dot end with totally forgot that the end with method existed. But like, hey, does this string end with... Oh, yes it does. Fantastic. And these are generally how we compare two things. But is life ever so simple that we only have to compare two things at a time? Of course not. That would make things so much easier, but life doesn't work that way. So we have the OR operator, which is the double pipes. This can be found by holding shift, and it should be the key above the enter key on your right hand side. And we also have the AND operator, and we're going to talk a little bit about that. Or the double pipes will evaluate to true if one of the conditions are true, and evaluates to true if both are true. So let's give you an example. Breed equals corgi. I used to love corgis. Now I think they're kind of overrated. They've become cliche. Age equals 2. And so what we do is that we can say breed equals corgi, or age equals 3. Galen, what do you think? What is this going to evaluate to?
True.
I'm sorry, were you asking me?
What do you think this is going to evaluate to?
True.
True.
Because one of them is true.
Yep. Or is going to be looking for if one of these is true, and we hit enter, and that's going to be true. Right. And to kind of do the contrast, breed equals corgi, and age equals 3. This will return false. Nope, did I? Nope, I did not. I typed the same exact thing. My mistake. There we go. This returns false because AND is looking for both sides to evaluate the true, and only when both sides will evaluate the true will this kind of thing happen. Cool. All right. Any questions so far about these conditionals? Alex?
This might be a silly question that you've already answered, but what happens if you just put 1 ampersand?
1 ampersand?
Yeah.
Don't know. Let's find out. Freaks out. Doesn't let us do it. All right. All right. Today's the best day because it's music video day. And as we get into conditional branching, I'm going to play music video, turn off the recording. Although I do think that Becoming a Wizard of Cheese is also up there. So you saw some examples of these conditional branching in a language called Python, but let's talk about what it would look like in Ruby. The most simplest of conditional branching is a one-branch conditional. I think that a good real-life example is, anyone here remember the old Choose Your Adventure books? Back in the way, like, conditional branching is essentially that. If condition is A, do one thing. If not, do another. And potentially you can add on more branches. So if we were writing some software for, say, a high school, we could do something like if GPA is greater than or equal to 3.8, we can run the method invite to honor roll, and we end it. And this is, at its core, the most basic form of using if conditional in Ruby. If whatever is after the if is evaluated in an if statement. If whatever's in there is true, whatever is between the if and the n gets run. If it is not, if this returns us a false, it will ignore whatever's in the block and keep going. So let's say do a GPA equals 4.0. It's going to be like, okay, we had an if statement. What comes right after the if statement? GPA greater than or equal to 3.8. Well, it's a 4.0, so this evaluates to true, and the method invite to onroll gets run. We change this to someone who is less good at high school. I was someone that is less good at high school. GPA is 2.0. We're going to get to here and say, okay, GPA, is that greater than 3.8? Greater than or equal to? It's going to be no, so nothing happens because this does not get run at all whenever this is hit. Cool. Questions about the syntax? Senya?
Are we going to talk about if else?
Yep.
Okay. I guess I have a question. How many else's? Is there a limit on else's or not? But if we cover it later, then.
Yeah, we're going to talk about that later, but I would say just to answer the question right now, we can have as many branches as we want. However, if I've got like 20 branches, I need to think like, is this the best way to do it? Like, can I be doing something a different way that makes this less complicated?
I
Right?
got
Because I think that you don't want to make 20 branches. You don't want someone that's looking at this to be able to have to go through 20 things to figure things out. If we're hitting like, and I'm not saying like 20 is the number, but if it feels like a lot, maybe we should rethink things.
Got it.
Yep. Cool. Good question. All right. So, kind of like building on what Ksenia said, like, what if we want to do other things? Like, we want to have like more than one thing, more than one possibility, and we can do that by using the else. And so, what that might look like is that let's set up a situation where if we want to spend a lot of money, we go out to eat at a restaurant, at a fancy restaurant. Otherwise, we stay at home and cook at home. So it looks something like this. If spend money equals true, fancy dinner, else cook at home. Oops. This should be a double. Right. And so let's talk about what happens each time. Spend money equals true. When spend money equals true, right? We're going to set spend money equals true. Oops, there we go. So we hit the conditional. Spend money, is it true? Yes, it is true. So because this here evaluates to true, we are going to run this line of code, fancy dinner. After this gets run, nothing else happens. Whatever else is in the conditional is ignored, and we just move on to whatever happens like down here. Let's change this to false, spend money is not true. This evaluates to false, and so this line of code does not get run, but this line of code does get run. Again, this evaluates to false, so it will ignore what is in the first block of code here and go to the else. Questions about this syntax? Dougie?
Is it a Ruby thing to use
Maybe call
my
your
audio
IT
just
guy
went
back. Does he
nuts.
actually go
To
to the building, or
use
he just gives you guys,
two equal
like,
signs, or is there no
advice?
case in which we'd use triple equals? Or
We live in a land where there is no triple equals.
good deal.
Okay.
Okay.
I know, I understand the question, and like we live in this world now. You live in this world now, where things will work the way you expect them to. I guess that is the best way to describe it. All right. So to kind of add on to this is like, well, this is kind of this condition, and else is kind of like this catch-all, like for every other situation. And so we can also create more branches. For example, let's go back up to this one. If GPA is 3.8, invite to honor roll, and we do the else if, and it just bothers me there's no E in there. Like, why not have the E? GPA is greater than 2.0. Graduate. Else. Right, and how this kind of works is that for a GPA 2. Let's do greater than or equal to. GPA 2.0. Is the GPA greater than greater than or equal to 3.8? No, it's 2.0. So we ignore this here. We go to this next condition. Is GPA greater than or equal to 2.0? Yes. So we run graduate and we ignore the Cool. Let's 1.3. Is it this value? No, it's not. Ignores this. Does it meet this condition? No, it does not. Ignores this. And because it's the last thing, we run the the one thing I want to note for you is that when you are creating conditionals in this fashion, it is very important that you are aware of the order in which you're creating conditionals. I'll give you an example. What if I was to do this? Oops. Now, by doing this process, we expect that a student with a 4.0 GPA to be invited to the honor roll. However, we hit this here. Like, yes, 4.0 is... Oh, wait. I need to change this as well. Graduate. If the GPA is greater than 2.0, which it is, 4.0 is greater than 2.0, you're going to graduate. However, the expectation is that because you have a 3.8, you should be invited to the honor roll. So it's super, super important that you are very careful as to the order that you are placing your conditionals in. In general, more specific should go first, and they should widen out from there. Questions about the else if thing, Andrew?
Yeah. Is there an exception to that general rule for, I guess you said from the specific or the less specific to the more specific?
No, it's more specific to the less specific.
Sorry. Yeah. Is there? Are there exceptions?
I mean, I can't think of any, but that doesn't mean there aren't any. I think that logically you're always gonna structure these things in this way because that's how we don't want any situations like this what we have right here where a 4.0 student is graduating and not invited to the honor roll.
Yeah, I haven't encountered it in the wild.
Well, yeah, so I can't think of I can't think of top of the situation. Doesn't mean they don't exist, but in general, I've not encountered that. Cool, Dougie.
Yes, sir. That's
Would an opportunity for refactoring kind of be if GPA is greater than or equal to 3.8, graduate and a double ampersand invite to honor roll? Would that work, or would it? Is that not a good idea?
Yeah, well, the thing is that this is like kind of a contrived example.
Mm-hmm.
Just kind of illustrate how the flow things work. You can do whatever you'd like in your code that makes sense. Like I guess it's kind of implied that they would be invited to the honor roll and graduate. Like it's kind of like all in that batch. But
Okay.
this is really just kind of illustrate kind of the flow of things happen.
All right, thank you.
Yep. Joey?
from like a syntax perspective, can you
Uh-huh.
drop the else if
Yeah.
you don't need the else condition, or do you need to include it to say like else do
Yeah.
nothing?
Yeah, so if I were to do this, if I were to comment those out and pretend these didn't exist, this would still work. However, I would recommend for every conditional you have, you should have an else statement because it'll catch anything you didn't plan for.
Got it.
I think that it's not it's like Ruby's not going to yell at you for not having an else, but I think it's just a good practice to have an else unless it's a situation where you know there's only going to be two outcomes.
Got it. That makes sense.
Cool. Good. Yeah. Cool. Good questions. Good questions. All right. Cool. Let's take a 5-minute break and we'll come back and talk about looping. Let's be back here at 11:38. 11:38. Cool. So that was a quick intro into loops. And loops are really kind of the most one of the best things about computers, because computers are built to make our lives easier. And I think that the things that computers do really well are to perform simple repetitive tasks over and over and over again very, very quickly. So in this video, we saw an example of what's called a for loop. And the good thing is that for loops are annoying to write because you always somehow miss the count by one, and you have what's called an off by one error. And they're kind of annoying. But like the good news is that Ruby gives us some more fun loops that we can do. And so the first loop that we're going to look at is the times loop. And a times loop executes a loop a certain number of times. So we, for example, 5 dot times do. I want a burrito. If I run this, we have print to the screen, I want a burrito 5 times. Cool. We can also include a block variable that tells us which iteration of the loop is running. So we can do 5 times do num, num, like this. And it'll tell us which thing on the iteration we are on. That's fantastic. 0, 1, 2, 3, 4. Questions about the times loop? The times does not have to be run on like a number. We could do something like loop times equals 5. That is something that works. Jahara?
So in the example that you just had, you had 5 times do and then num. How did it know that you wanted just the number? Like, is that just a placeholder? Would it have cared if you put like purple sparkles? Would 0 through 5 still
That's a good
come
question. Yeah. The block variable is just saying like, hey, this is what we want. This is when we put the thing in pipes like this, we're declaring this is what I want to use as the name of our block variable. And like you said, this can be purple sparkles. And I go down here. Still works the same. We're just declaring, hey, when I go through, this is the variable name I'm going to use. And so what happens is that because we're looping 5 times, the first time through, purple sparkles is going to be 0, and it's going to print that out to the screen because we start counting from 0. Second time through, it's going to be the 1, and so forth, so we get to the end. It works a little bit kind of like each in that regard. Right. Cool. Catherine?
I guess this is kind of a weird question, but so you can do puts purple sparkles, but then can you get it to like print something after the 0 and after the 1? Like, could you
Yeah.
like say this number of burritos or this
Yeah, we can do that.
burrito count or something?
Do that.
String can't be coerced to integer.
No, it's this. Let me do this differently.
Okay. Cool.
Yep, it doesn't matter what you do in the block. Like you could do whatever you want there. You just have access to that number. Cool. Moving on, we got the times loop. I'm just going to comment this out. So we're gonna run. We do more things. Next is that we have the while loop, and the while loop looks a little something like this: while condition do thing. Right. And so long as condition, whatever this condition is, evaluates to true, it will run whatever's in the block and keep going. So an example of this is while parking lot, parking spot dot full, and this is just like, we're just pretending that this method exists. We are going to keep driving. Like we are going up and down the rows at the shopping mall back in the day when we went to shopping malls, and you keep driving. Is this spot full? Yes, it's full. We go to the next spot. Is this spot full? So forth. And when we find a parking spot that is not full, we exit the loop. We don't continue to drive, right? Unless it's in a spot you don't want to park or something like that, right? The while loop continues to loop and execute the code in the block until we find until like the condition no longer meets it. Alex?
So is that a kind of loop that needs by default a thing to tell it to stop, or will so it doesn't break your whatever?
Yeah. So the things that like at the point is that like there's also going to need some other code that will change parking spot full to like false. Otherwise, you get into the situation you keep on driving. Every loop needs some kind of condition to tell it to stop, and it's up to you to kind of make that happen. That being said, as you work on your projects, you may find yourself in a situation where you get into a loop that never ends, like you get into an infinite loop. To make your Ruby stop doing that, hit Control-C. That will force the stop of your program. And that is Control-C, not Command-C. This right here is like just some sample code, like just some sample of how it could work, how it could look. We're not going to go too deep into the implementation details of it. Other questions about while? Cool. Dougie?
So I think it actually might have been answered in the last question that was asked, but in the event that you do want that to eventually, it's not like you would put an else or something in there. You would
No.
just have it set so that eventually the parking spots weren't full.
Something else has got to trigger that.
Gotcha.
We're just talking about like the basic kind of syntax that has to this loop up.
Okay.
Yep. Cool. Good question. Awesome. Ryan?
Yeah, I guess I'm still confused on the 5.times do number.
Yeah, let's go back up.
So the idea behind that was the 5 is an integer.
Huh?
Why did it print out 0, 1, 2, 3, 4 if 5 is an integer?
Right. So how times works is that when we pass in a block, it's going to count like at which iteration I'm going through. It's going to count up to 5. That's why it does that. 5, yes, 5 is an integer, but it's like saying like, hey, I got to run this 5 times. I'm going to count which step I'm on. That's just how times works.
So is it printing out an index position?
Yeah.
All right, that makes sense.
It's essentially, so you talked about each yesterday. Very similarly, let's say like this, let's change this back to 5. 5 times do is almost the exact same thing as 0, 1, 2, 3, 4. And, you know, whatever you have. These are essentially the same thing. Does that kind of like clear it up a little bit more?
Yeah, it helps.
Yeah, but I think that they made the times method because like this is a whole lot easier to read than this. I think it's easy to see like, yeah, I'm gonna do this 5 times. Cool. Awesome. All right. We got 2 other kinds of loops left. And we have the until loop. And that looks like this. Until the condition end. And this here will execute so long as this condition evaluates to false. It's kind of like the opposite of while. And so to do this, but using an until loop, I would make it like this. Until parking spot dot empty. Right, so it's like until we find an empty spot, keep driving. Personally, I'm not a fan of until because it makes me, you know, thinking that like have to like negative things. So I'll try to structure things the other way. And like, and also I want to mention that like when I'm talking about stuff, I'll be very explicit about things you have to do and things you should do, and things that are my opinion. Like personally, I feel that it's easier for me to think in terms of while as opposed to until, just because how negatives are structured, and that works for me in my head. If it works better for you in your head, do that. Like we are not here to judge like if you like to do negatives in a certain way. Like it does, in the grand scheme of things, it doesn't matter. Do what makes sense to you. I feel that while provides me for fewer opportunities to use nots and not nots, and therefore I will not mess it up. I write code in a way to minimize the possibility that I will mess something up. Because I know that I'm not really great at figuring out the knots in my head, and I often have to write them out. So I'll just avoid that whole thing to start with. Cool. Any questions about until? Cool. And finally, the last one. And this one is going to be just the and this is going to look like this. Loop do end. This loop has no conditional. And by having no conditional means that it will run until you make it stop. And you would use the break keyword to end a loop do. So something that this could possibly look like is if I did this. And what we're doing here is we're setting count to 0, and we're going to loop. And every single time I go through the loop, I'm going to add 1 to the count. And as soon as my count hits 3, I'm going to stop. And a loop do will run until you decide somewhere in your code to break it. And again, like using the loop do in this fashion is potential situation where you get yourself into that infinite loop. Jennifer?
I think I had something like this come up before that doesn't return break the loop too, but then also does something else, or no? Something similar. When I was working on, sorry,
return would break the loop.
Does it do anything additional, like where break would just be better to do versus return?
Yeah. Well, so things that break will break the loop, and then whatever is underneath will then run.
Mm-hmm.
Whereas return will it'll whatever method, it won't run anything else. It just stops right there.
So basically, you never want to do that. Almost
I mean, never. I never want to say almost never, because I always feel there's always a situation where you're gonna have to do it. You're gonna have to do it this way. And that's not like a value judgment on the situation. It's like it's going to be a situation where it has to work this way, or there's going to be a situation where it has to work that way.
Okay.
Each tool has a different use case, and there's no value into one over the other. Like you don't screw in screws with a hammer. You could, not a great idea, but like the same. Well, you don't hammer things with a screwdriver. You could, but not the best tool for the job. Right? And in that, we're not saying we're nowhere in there are we saying are nails better than screws and screws better than nails. They are appropriate for different tasks. Although I will say it is more fun to hit a nail with a hammer. That feels more fun. Cool. Other questions about loops? You want to open up loops or anything else you've covered today? Cool. You are all set for this morning. We'll have our first independent challenge at 1 o'clock. There'll also be an attendance thread, so keep an eye out for that. We will post that at 1 o'clock this afternoon. See you then.